Okay, dear students, today we will discuss the chemical reactions of ether. It is very important reaction from an exam point of view. Like alternate years, they have given such questions, right? So we will focus on this reaction very deeply, and you have to just go through 3 or 4 reactions to understand or to get the concept. So that will be enough for it, right? Suppose the reaction is involved in Hi, H plus and okay, H plus Hi means H plus and I minus, H plus and I minus. This H plus will go to some negative species, that means electron rich species, as it is electron deficient, and this I minus is electron rich, that means it will go to electron deficient, right? So when this reaction takes place, the ether breaks into 2 parts. One will become the carbocation where I minus will get joined, and the other will be some anion where H plus will get attached. You have to observe both the cases, right? Suppose in the first case we see that here one is ethyl part and other is methyl. It is known as ethyl methyl ether, right? So as we see that here cleavage of CO bond takes place. So this CO bond can break from either side. From side A we will get this. If it breaks from side B, we will get this. First of all, we will consider the breakage takes from side A. If it is breaking from side A, that means it will get removed and you will obtain this one CH3 CH2 plus, and the other species which get removed is OCH3, right? And forget about this. Now if we break the CO bond from side B, then we will omitting this part, then we will get CH3 plus and this part CH3 CH2O minus. If I ask you which carbocation is more stable, you will definitely answer this one, CH3 CH2 carbocation is more stable. That means this carbocation will get attached to I minus. As I told you, Hi breaks into H plus and I minus. This I minus will go to the electron deficient species. Since this carbocation is more stable, so the generation of ethyl carbocation is preferred over methyl carbocation. So I minus get attached to ethyl carbocation and we get ethyl iodide, and the remaining part here we can see that CH3O minus. If CH3O minus is here, then the H plus part get attached to CH3O minus. Then it becomes CH3OH. Here you can see. Okay, this is the first reaction. Next we will move. Second reaction is in between phenyl methyl ether. Okay, so here also same condition we will apply. If we will break from side A, then we have to omit this part. This is benzyl carbocation. Okay, and the other species is OCH3, right? And if we break from part B, then you will obtain this methyl carbocation and this phenoxide ion. I hope you remember from the acidity of phenol that phenol is more acidic. Why? Due to the presence of phenoxide ion, it undergo resonance. Here the lone pair is available. Lone pair undergoes resonance and double bond is created, and in same way when we consider in the beginning of the molecule, this oxygen is having lone pair, so this oxygen will undergo resonance and here it will create double bond, and when it is creating double bond, it is very difficult to break from side A, so it will definitely follow this path. So when it is following this path, that means this you will generate this methyl carbocation and this one is phenoxide ion. That means O minus here, and this O minus gets attached to H and I minus gets attached to this CH3I. So here comes the result. Always remember one thing, that when you are considering phenyl and whatever the alkyl group, that doesn't matter. Simply you have to see if there is any phenyl group attached directly to the oxygen, it will definitely give phenol, and the other part, the alkyl group, will get attached to I minus. So you have to consider this fact, that whenever there is a phenyl group attached to oxygen, then we will obtain OH with HI reaction. Always and the other alkyl part will get attached to I. Always remember this thing. This is the second reaction. Next we will move to the other reaction. Okay. Now see, this is the third case. Here you can observe that to benzene a CH2 is connected, then oxygen is connected. If it have been the oxygen is directly connected to benzene, then the earlier reaction would take place and phenol will be the result. But in this case, benzene is first connected to CH2 group, which generates this if it breaks from side A, and the other part is this, right? So it is benzyl carbocation. I hope you remember benzyl carbocation is also stable. Why? Due to resonance. Here electron donating capability comes from the ring. So due to the stability of benzyl carbocation, the benzyl carbocation gets attached to I minus. I minus get attached to benzyl cation, and other we get the methyl alcohol. So three reaction we have to always keep in mind. First is when first reaction we have observed, we will determine the product depending on the stability of alkyl groups. For example, whether ethyl is more stable or methyl or whatever the other alkyl group, we have to consider this when both sides there is an alkyl group, right? And second thing, you have to think whether the reaction is having phenyl group attached to it. If it is directly attached to oxygen, then you will always obtain phenol as your product. And finally, if there is a carbon in between oxygen, then carbocation will be generated on carbon and I minus will get attached to benzyl carbocation. So these three reaction you have to remember for today, and it is very important for the examination point of view, right? So I hope you guys have understood. Any doubt should be mentioned as early as possible, because once doubt remains, it will always be a doubt. It will never get clear. Ask right now. Thank you.